In this video we're going to learn how to make functions. We're going to make a function to calculate the area of a triangle, not just a right angle triangle but a triangle of any shape by inputting the lengths of each of its sides. A function is a separate part of a program that performs a specific task. In this case there are parameters sent to the function. The parameters are the sides of the triangle. This function calculates the area using Heron's formula and then returns it. Now let's make the program. As usual, we start a new project. We call that project Functions. We make a new folder called Functions and we select that folder. We make the form a bit bigger. Click on the toolbox on the left hand side, add and drag a button onto your screen and position it as I've shown it. Change its name to BTN Calculate and change the text to Calculate.
That's what the girl in our tutorial was saying.
Like, how are we going to do this? If I ask for my predicted Gracie's case, I don't even know.
I don't know what to do either because I want to go uni, but
yes, everything is against it.
and I've got to write personal statement as well. Like, they think I know how to do that. I can barely write a paragraph.
Like, this is...
Jerry, you want to go uni next year?
Shoot, fuck no. I'm not going to stay.
From the toolbox on the left hand side, drag a text box onto your form and position it as I've shown and give it a name side_A in lowercase. Similarly, from the toolbox on the left hand side, drag a text box onto your form and position it as I've shown and give it a name side_B in lowercase. And again, drag a third text box onto your form and give it a name side_C. We're going to make some labels to the left of these text boxes, so I'm moving them all over a little bit. From the toolbox on the left hand side, add a label and change its text to first side length. Change the font if you like and make the text a bit bigger. Using copy and paste on the first label, make a second label called second side length and a third label called third side length. Click the Run button to check it works and see what it looks like. Now we copy and paste one of our other labels that we created and change the name to LBL display area and change the text to triangle area. Now let's double click on the calculate button and enter some code. Now we will dimension or set up 3 single precision numeric variables to contain the lengths of the sides of our triangle. We'll call these SNG A, SNG B, SNG C. The A, B and C will be in capitals. Next we will set up a variable to contain the answer. We'll call this DBL triangle area, and notice it's a double precision number. Click Save and check it runs. Now we're going to create our function to calculate the triangle area. We will call this function triangle underscore area, and 3 values are passed to it, the lengths of each side. We'll pass these by the values of the variables, so we're entering by val, and we have to set up 3 new variables in the function to do this. They'll be called side 1, side 2 and side 3. Within the function we're dimensioning 2 other variables. These are just local variables as they're within the function, and they're called P as single and area as single. Notice P and area are both underlined in green. This is not a critical area, it's just a warning that we haven't used these values yet. We're going to use P as a temporary value in the calculations, and we're going to return the value area from the function. Now we're entering the P components of Heron's formula to calculate the area of a triangle. This needn't necessarily be a right angled triangle and could be any shaped triangle. And now the rest of the formula. Notice we have to do math.square root to calculate the square root. Now we type in return area, which sends the area back to where the function was called. If we run it now, nothing will happen because we haven't got anything written in the button calculate area part of the program that's run when the button is pressed. First we need to extract the lengths from the text boxes containing those lengths. We make our variable SNG A equal to C SNG, which converts to single from side underscore A dot text, which is a text box containing the length of side 1. Similarly we do this for side 2 and side 3. We now need to call the function. We do this by dbl triangle area equals triangle underscore area, open brackets, SNG A, SNG B, SNG C, which are the sides. It's the triangle underscore area part that actually calls the function. Now we've got the value for the area calculated, we need to just display this in the label. We do this by LBL display area equals the value that was returned from the function. Notice that the AND sign concatenates or adds something to the end of the string. We're converting the double value for the area to a string and then adding it to the LBL display area string. We will check it works with a 3, 4, 5 triangle. We'll use a 3, 4, 5 triangle because 3 squared equals 9, 4 squared equals 16, 9 plus 16 equals 25, which equals 5 squared. Yes, it works. It gives an area of 6, which is 3 times 4 divided by 2. The only problem is I've got 2 areas in this, so I'm going to delete one of them. This is the only one that I need, the one called LBL display area. Now let's save it and check it runs again. For this we're going to use the values of 30, 40 and 50 for the lengths of the sides. Yes, it works. 30 times 40 is 1200 and that divided by 2 equals 600. Experiment with the output and see how creative you can be. If you haven't subscribed already, please click the link to subscribe.